In this video, we're going to take a look at how complex numbers can be used to find the nth root of I. So first of all, we're going to consider the graphical representation of a complex number. So we've got an image of the complex plane going from -1 to +1 on the real axis, and then from -1i to +1i on the imaginary axis. And we've got a vector here, an arrow drawn to represent a complex number on this complex plane. The magnitude of this arrow is represented by the letter R, and the angle from the real number line is given by theta. Now, the real part of this, the magnitude, is given by R cos theta, and then the magnitude of the imaginary part is R sine theta. So if we just put in plus I to complete this, overall we've got a complex number form. We can simplify this to R brackets cos theta plus I sine theta. So this is representing the complex number given by the red arrow shown here. And we can see it in graphical form, and then we can also see it in equation form. So now we have this, we can think about what's the graphical representation of I. Well, R equals 1 and theta equals 90 degrees. So if we put those values in, we get cos 90 plus I sine 90. Now, of course, if we do a 360 degree rotation, we're still at 1i. So it also works if we have cos 90 plus 360 plus I sine 90 plus 360. In fact, we can go round any number of times, and as we go round, for each 360 degree rotation, we get back to 1i. So we can actually write cos 90 plus 360k plus I sine 90 plus 360k, where k is the number of rotations that we've made around the circle. Okay, so now that we have this equation for I equaling cos 90 plus 360k plus I sine 90 plus 360k, we can take the nth root of both sides, and this will get us on track to finding the solution to the nth root of I. Now, it turns out that you can simplify this to cos 90 over n plus 360k over n plus I sine 90 over n plus 360k over n. I'm not going to show you the mathematical proof for this in this video, but this is a result that we can obtain. Okay, so k is an integer from 0 to n minus 1. That will give us all the unique solutions to this problem, or it can also be written like this: k equals curly bracket 0, 1, all the way to n minus 1. Okay, so if we think about a graphical representation of the nth root of I, so we've got an arrow here, magnitude 1, and it's rotated by 90 degrees divided by n. So n is whatever order of root that we're after. If we were to do the root of n times the root of n, we'll rotate another 90 degrees over n, and will be at this point represented by the purple arrow. And in fact, if we keep multiplying the root of I, the nth root of I, n times, we'll have eventually got round to 90 degrees, and we'll be back to I. So it's just a bit of a graphical way of thinking about what the meaning of the nth root of I. Now, this is only one solution. There are other solutions. So we'll sort of take a look at this a bit further and unpack this a bit further. Okay, so let's think about the square root of I. This is where n equals 2. When k equals 0, we obtain cos 90 over 2 plus I sine 90 over 2. So we get a vector here, this red vector, this red line representing our complex number, and the angle is 45 degrees from the real axis. Okay, when k equals 1, we obtain cos 90 over 2 plus 360 over 2 plus I sine 90 over 2 plus 360 over 2. So this is shown by the red arrow pointing in the opposite direction. and this is 180 degrees rotated around from the first solution. What about the cube root of I? Okay, so n equals 3. When k equals 0, we obtain cos 90 over 3 plus I sine 90 over 3. And that is represented by this red arrow here. We're now 30 degrees from the real axis. For k equals 1, we have to add on 360 divided by 3, so we go round 120 degrees. That's the second solution. When k equals 2, we go round another 120 degrees, and we get the third root. So for the cube root, there's 3 possible solutions. Fourth root of I, we've got 4 solutions. The first one is 22.5 degrees from the real number line. The next one is 90 degrees from the first solution, and we keep going round at 90 degrees, and we get our 4 solutions. Fifth root of I, we get 5 solutions. The first solution being 18 degrees from the real number line, and then all of the other solutions are separated from the next by 72 degrees. And then sixth root, there's some solutions here, and you start to get the idea of what's going on. Okay, so that's been a video about finding the nth root of I using complex numbers. I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.